Hi, I'm Sergey Sokolenko, a co-founder of Tower.dev. Tower allows you to run Python data and AI applications reliably in production. What it means is we provide a managed platform where you can deploy your Python apps ranging from ETL to inference, and we take care of management, the infrastructure provisioning, security, and everything else. In today's demo, I wanted to show you how easy it is to use Tower for local development and cloud remote execution. We'll take an example of a DeepSeek R1 model, summarizing an issue in GitHub and all its related comments, treating it as a chat, and creating a recommended course of action, responding to that issue. Let me show you what I mean. For example, for this particular GitHub issue that suggests the addition of a new feature to a particular software project, there's a proposal by the original user, as well as multiple comments by the repo maintainers, community members, and the user himself. Wouldn't it be nice if we had an automated way to summarize all the great ideas in this thread and propose the best course of action? We'll use Tower to build this app, so let's jump into it. So the first step to develop a Tower application is to write Python code. Let's get into Cursor and write some Python. I'm currently in the Tower examples GitHub repo, and I cloned it, and I have a local repository with the source code of the application we're trying to develop. Go into the DeepSeek Summarize GitHub folder. This is where the contents of this application is located. Here I have a summarize.py file. This is my main script of the application, and I have some additional files such as the Tower file, the requirements file, and a few other things. Let's look at the summarize.py file. If you remember, we are developing an app that uses the DeepSeek model to summarize an issue in GitHub. So the first step we're going to do in this application is to get some parameters that identify the issue that we're trying to summarize. That's exactly what's happening in these 3 lines of code. We are getting the identifying info for the GitHub issue, including the issue number. And secondly, we're going to get the output parameters of our application. We need to know where to write the output of our smart R1 model, and we'll get the URL of the output bucket. And lastly, we're also going to get the type of a model to use. In most cases, we'll parameterize it with the DeepSeek model, but perhaps we want to try out some other models as well. In the first set of steps, we're going to acquire the contents of this GitHub issue, and this is exactly what happens in the following 4 lines of code. We read the GitHub issue, and we divide it into the issues and comments arrays. And then we start building our chat, because if you remember, we are trying to use DeepSeek. DeepSeek is a LLM model. It responds well to prompts and chats. It can react to context in a chat. So we're going to convert a GitHub issue into a chat. The original issue will become one of the first chat messages, and all the subsequent comments will be chat messages as well. And the top will have a prompt. And the prompt will say something like, summarize the GitHub issue and identify options for addressing the original issue. So we're going to convert the entirety of the issue into a chat. And then we're going to actually understand which environment we're running in. This is one of the functionalities that Tower provides to you. You can run Tower applications in multiple environments. In most cases, you will have the same variable settings and the same config settings in these environments. But in some environments, the values of your variables will be different. For example, in production, you might use one set of credentials. In development, you'll use another set of credentials. In most cases, you don't need to know which environment you're running, because Tower takes care of injecting the right secrets. But since we're trying to do local development and remote execution, actually, in our case, we do want to know the environment we're running. And this is how I'm getting and understanding which environment I'm in. So if I'm in the local environment, I will use, in this app, I will use Ollama's inference server, a local inference server that runs on my development machine to process this chat. Ollama will use a DeepSeek model. It will use a model with a smaller number of parameters. It's what's called a distilled model that uses just 14 billion parameters. However, if I am running in production, so if the environment is not local, I'm actually going to use an inference provider. In my case, it will be Together.AI, but I will interface with this inference provider through the Hugging Face's new hub functionality, which is basically a router for inference calls. I'm doing this because if in the future I want to change the inference provider from Together.AI to something else, it's easier for me if I can change a couple of parameter settings in Hugging Face instead of rewriting my application. So at the end of this code block, I will have a response variable, and the response variable will be the output of the DeepSeek R1 model. The rest of the code is just handling the response of this model. So first of all, I will output this response into my output for debugging purposes, and then I will prepare this response for printing out into a file, and that's what the last lines of code mean. They export the response both as a single response of the model as well as part of the full chat. And that's all the code of our application. Let's go and run it in local mode on Tower.
To run my app on Tower, I'm going to switch to a terminal. And I'll first start the Ollama inference server. As you remember, we'll use Ollama for local inference so that we can use the Apple Silicon GPUs. And I'll do this by typing in ollama run and the name of my model. I'm using DeepSeek R1, the 14 billion parameter version. Ollama is running, and now I can go into another terminal window and actually start the Tower application. Just to give you a quick overview of what's inside the folder that contains my Tower application, we reviewed it in Cursor. As you can remember, I have a summarize.py file. This is my main script. There's a requirements text file. There are a set of additional Python scripts in the core folder and the Tower file. So to run the app locally in Tower, I will recall one of the previous commands that I typed before. It's called tower run -- local, and then a set of parameters. You will recognize the variables that we reviewed earlier in the demo. These are the input identifiers for the GitHub repo issue, issue number 933 in the DLT GitHub repo. And these are my output parameters. They specify the folders in which I want to write my responses. It shouldn't be a surprise, the model that I'm trying to use is DeepSeek R1 14B, the same one that I just launched in Ollama. So let's get this running. As Tower installs the application, installs all the dependencies of the application, it does exactly what it would do in the cloud. So you can see all the dependencies that are needed by your app. You can debug issues if you run into any. It gives you kind of the same experience as the app would go through in the cloud in Tower. And so I'm getting now the first responses of my application. So all of these messages are actually produced by my code, and they're produced by some of the earlier lines of code in my example, the ones that are reading from GitHub. I have a set of messages telling me that there are some merge warnings I should be taking care of in the future with my code. After some time, the application will get to the LLM chat response processing, and it's at this point I wanted to show you that GPUs will actually be be used in the application. Let me quickly open up the activity monitor. Right, so inference is already running. As you can see, Ollama is consuming GPUs. It's taking all the processing power it can get, which is exactly what we wanted. It takes typically 10 seconds for my locally hosted LLM to produce the results. And now I'm beginning to see the output of DeepSeek R1. This is the summary of the recommendations for the GitHub issue. The model tried to understand what the original submitted issue was, and it created recommendations, things like use the write-ahead log of Postgres, take into consideration schema evolution and column control, and so on. So it's a meaningful, useful interpretation of a feature request that the user submitted, and all of the commentary by the original author of the repo. Great, so this was local inference. How about running this application in production, where I'm not running locally anymore, where I'm running in the Tower Cloud, and I'm using serverless inference. So for this, I'm going to call Tower again and have a small change in the parameters. Specifically, I'm going to specify the environment being the production environment or prod. The parameters will remain largely the same, except that I will specify one extra parameter, the inference provider equals Together, and the model name is slightly different because this is how Together, the Together.AI inference provider, that's what they call the DeepSeek R1 model. There's an extra parameter for max tokens. That's usually useful if you want to control the costs of your inference. So let's run this app. Well, this one was much quicker, and the reason why it was much quicker was because the job is now submitted and is being running in the Tower Cloud. Let's go to Tower. And see how this job is being executed. All right, so in Tower, I have 5 applications. One of them is the one that I'm interested in, DeepSeek Summarize. And as we can see, the application is running right now. Let's go into it. Here's my latest run. Let's see what the outputs and responses are. They should be coming up pretty soon. Great, so these are the messages that our GitHub data acquirer produces. And at some point, I should see my inference call results as well. They typically work faster in serverless inference because we are using a provider who's probably running pretty sophisticated hardware at the back end, NVIDIA H100s, which are much faster than my local GPUs, but produce the same output. And as we can see, here's my debugging output. It's the same message I saw locally. So I am getting the same, almost the same results. Remember, locally I'm using a distilled version of DeepSeek R1, the 14 billion version. In production, I am using the full 671 billion parameter version of DeepSeek. And I've checked these outputs before. Trust me, the full model provides more meaningful output. So it does make sense to use the full model eventually in production. Well, great. So in this demo, what we saw was we developed an application that uses Tower's local mode to run local inference on DeepSeek R1. It uses ollama to serve the inference and serve the model. But then when we are ready to move into production, it was just one simple change in the call command, and Tower executed the run in the Tower Cloud, and instead of the Ollama servers, we use the serverless inference providers provided by Together.AI. We think that's how future application development will go, and we would be happy to have more of you trying it out and giving us a shout.